Maestros, buenas tardes. Continuamos con nuestra tercera ponencia del día. En este caso estamos hablando de laboratorios de realidad virtual para la educación 4.0, impartida por el maestro Serkan Kanikoglu y quien es el científico desarrollador, y Emi Gundogan. Esta ponencia, maestros, va a ser impartida en el idioma inglés, por lo que es probable que algunos de ustedes requieran de intérprete. Les voy a dar la instrucción para que sean ustedes tan amables de seguirla y puedan escuchar al traductor de manera simultánea. En la parte inferior de su pantalla de Zoom van a encontrar un símbolo que simboliza un globo terráqueo, un círculo y con la descripción interpretación. Si ustedes teclean ese botón, van a poder ver dos opciones, español e inglés. Entonces les pedimos que tecleen la versión en español. Repito, para aquellos que no me hayan podido seguir, esta ponencia va a requerir de traducción simultánea para aquellos que no manejen el idioma inglés. Entonces les pedimos que sigan la siguiente instrucción. En la parte inferior de su pantalla de Zoom van a ver un símbolo de un globo terráqueo con la inscripción interpretación. Al teclearla les van a aparecer dos opciones, inglés y español. Les pedimos que por favor tecleen el idioma español. Con eso ya van ustedes a tener la posibilidad de escuchar al intérprete de manera simultánea. En lo que realizamos esta acción, les leo brevemente algo del currículum del maestro Serkan Kanikoglu. Él ha completado su licenciatura aplicada en Ciencias Biológicas y Bioingeniería con la especialidad en Química de la Universidad de Sabancı, en Estambul, Turquía. Él es no solamente un científico desarrollador, sino un pujante académico. Tiene diversos estudios de pregrado y posgrado y actualmente imparte clases de biología y química en distintos grados dentro de su universidad. Parte de su filosofía es que él cree que los sistemas de educación híbrido son adecuados para los estudiantes, ya que les da una visión previa al contacto directo con los laboratorios. Son prácticas previas y de esta manera él considera que se fortalece la formación de los estudiantes, particularmente los de media superior y superior. Bueno, con su llegada a VRLab, él ha tenido un afortunado desarrollo, ya que su trabajo se está exponiendo en más de 20 países para muchísimos estudiantes a nivel mundial. Entonces estamos muy contentos, él es muy joven, nos da mucho gusto tenerlo aquí. Estará con él Emily Gundogan. Emily Gundogan cuenta con una licenciatura en arquitectura en la Universidad de Bilgi, Turquía. Posteriormente, continuó con su maestría en arquitectura en el tema de investigación como zonas de depresión, continuidad de espacios verdes y democratización de los espacios públicos en la Universidad de Bella Artes, Myanmar, en Sinan, Turquía. Hay un dato curioso que nos gustó mucho conocer. Ella estuvo un año en Michoacán, México, en la Universidad Vasco de Quiroga como estudiante de intercambio. Y entonces conoce algo sobre México y nos da mucho gusto. Ha trabajado con diferentes organizaciones en temas de educación, desarrollo, y ha estado trabajando en VRLab Academy desde su fundación. Y actualmente es la gerente comercial. Y les damos la bienvenida, Emi, Serkan, welcome. Nice to have you here.
Thank you so much.
Thank you. It's our pleasure.
It's really nice.
We're very excited to have you here. I know that you are in this moment in Turkey. It's night, correct?
It's almost, yeah. We can say 8:30.
Well, we really, truly appreciate the space that you are giving us and the effort. Please welcome and feel free to start whatever you want.
It's our pleasure. Thank you. So today I will be sharing my screen and giving you a presentation. And then my colleague Serkan will be sharing his screen, and he will be showing an experiment as a demonstration. And he will also show our platform and how we use it. I think you can see my screen. As VRLab Academy, we are developing virtual reality science experiments that are curriculum-based. And there are multiple ways that our platform can be used, such as the PC version or VR version. At the left part, you are seeing a computer laboratory from a medical university that they are using PC version in their physical computer laboratories. And at the right part, you can see the institutions that prefer to have VRLab Academy as VR version in their VR classes. And this is also our VRLab Academy workstation. Right now, there are multiple ways to use our platform. It's quite flexible, and with the distance learning in these days, for example, the usage goes this way. So the teacher shares their screen, and after they complete one subject, they perform the experiment to students, and then the students can perform it as a homework, as a we can say weekend project. Some schools also decided to grade their students, such as 30% going through from VRLab Academy. Right now, our system works totally web-based. So you just enter, just like any other website, using your username and password, and then press login. Right now, we have two different versions, VR version and PC version. For VR version, you need VR goggles and touch controllers, and PC version, you only need your computer and an internet connection. Right now, we have 10 different laboratories from biology to medical biochemistry, and we recently developed VRLab Academy Junior, which is for elementary and middle schools, and we keep developing both experiments and new laboratories. Let's say we get into the mechanics laboratory. These will be the experiments that I will be seeing. And of course, there are many more below. And here you can see a brief explanation about that experiment and two buttons such as start and manual. And at the manual part, these contain the experiment information forms in different languages, which we have adapted to. And you can see the theoretical information, tools and materials, and the procedural information of the experiment. And this is the experiment list that we currently have for high schools and universities. You can see many physics laboratories, biology laboratory, thermodynamics, modern physics, chemistry, and medical biochemistry. And as I said, we keep developing new experiments and new laboratories. And once you purchase a laboratory, when there is new updates or there are new experiments that we added, you automatically get that experiments and updates also. And this is the junior experiment list, which also has general cultural experiments inside of it. Yes, it's the junior. And in our platform, we have 3 additional sections, which is My Data, VRLab Academy Live, and VRLab Academy Webinar. In my data section, after I finalize an experiment, I am saving my data, which can be graphs or tables. And when I go to my data section, I can find this data, I can download it to my computer, and I can use it as my lab report. And in VRLab Academy Live, we have our live videos, which showcases the experiment from start till end that are recorded by our science department. And I'd like to show some screenshots inside of our laboratories, some examples. As you can see, we try to design the lab environment as realistic as possible, which they already rely on real scientific formulas. And you can see there is a tablet on the table, so you can grab it. And there are 2 parts, theory and experiment. At theory part, you can find the experimental information form, like you were finding in manual section. And at the experiment part, you can find the graphics and the tables. As you can see, you can change the voltage or the current as in electric laboratory that we are seeing right now. So the students and the users can input their own parameters. And when they change these parameters, they will be having different outcomes than each other's, and they can perform the experiments multiple times with different data. And many of you know the modern physics laboratory materials can be extremely expensive, and it's really hard for students to be able to perform it as much as they want. With VRLab Academy, they can perform all of these experiments by themselves, receiving their own data, and they can perform the experiment multiple times, getting different data, and they can share this with their professors, because in our experiment manuals, they will be also finding the blank versions of graphs and tables, so they can also fill them out. And for chemistry laboratory, for example, there's no need to buy consumables every year. You don't need storage. And for biology laboratory, it makes it possible to observe things that you cannot normally observe in real life. In our platform, we have more than 100 sensors that can vary from heat sensor to Geiger-Müller sensor. So the student can decide whether they need to integrate it to that experiment. They can go grab it from the sensor station, and then they can integrate it to their experiment. And we have lab assistants. This is Amy. We also have Rita and Bella. They are giving a brief explanation about the experiment. Why are we performing this? What are our gains? And also they give certain information, certain warning to students to walk through them during the experiment. Amy, Rita, and Bella. And we can check some customer impacts. So with VRLab Academy, teachers can give homework through the platform, and the data relies on real scientific formulas. So the outcomes will be the same that you get from a physical laboratory. And then you can get this, let's say, experimental data and compare it to your theoretical calculation. And academicians don't have to prepare the lab environment before the experiment, so this saves major time. And so you know that these experiments are mostly universal. So our experiments actually based on curriculums, and they are correlated with high schools and universities curriculums. And this is a research from Saga University, Japan, from 2019. And they yes. And they took EEG data from students. So this EEG data shows that students in virtual reality classes, they get 6 times a more concentration span. We can also integrate to LMS systems, as you know, learning management systems. By this integration, the platform becomes single sign-on, so the users don't have to put their usernames and passwords each time. And depending on the nature of the LMS, the teachers can see data about the students, like the time spent of the experiments or the graphs and tables that they received from the experiment. And we have academic collaboration opportunity. If we don't have an experiment that an academician is studying on, we can totally develop this experiment from scratch. With the collaboration opportunity, we get theoretical data from academicians, the scenario and needed materials as reference images, and our design team and software team can develop the experiment. Then we do the launching of this experiment in our website and social media accounts. We have developed medical biochemistry laboratory with 3 professors from medical school, and this is the spectrophotometry experiment as an example. And globally, we have partnered up with Intel and Lenovo. This is from 2020 BET Fair London. They have been using our software and their hardware. And we have a really excited project, which is Artificial Intelligence Science League. This will be held among the VRLab Academy user schools, and these schools will create student groups. We will be sharing 3 different artificial intelligence problems, and the student groups will share their solution algorithms, and our academic panel will be deciding on the final at Fundamental Science Museum in Germany. Yes, the finals will be in Fundamental Science Museum in Germany. Thank you for listening to me. Now Serkan will share his screen and he will be showing us a demo experiment.
So thank you, Emina, for that lovely presentation. Now I will be sharing my screen. So this is how our admin page looks like. The student will not see this page, but the teacher will. But the teacher and whoever has the admin access will see this page. We log into our website through website button. Then we log in with our username and password. We pick the PC version because we don't have the VR version equipment with us. And I will be showcasing a chemistry laboratory for all of you today. So we pick chemistry and we scroll down to the acid-base titration experiment. We have two options as to click. First one is the start, where we get in the lab and start the experiment. And the second option is the manual. So the lab manuals include 4 languages, including Spanish, English, Arabic, and Turkish. And now we will be looking at the Spanish manual. This is a template that we use for all of our experiments, so it's pretty consistent. We start with the subject of the experiment. It's acid.
One second, please. Can you hear me?
Yes.
Okay, we will ask you for a favor. We are trying to translate the panels at the same time. So we will ask you if you will so gentle to put the version in Spanish in your Zoom computer, in your Zoom platform. There is a small world down on your screen and says translation, and put it in Spanish so you will be able to hear the translation, and you will give some pause.
It's under the interpretation, right?
Correct. Interpretation.
Yes.
Correct.
Sorry. Yes.
No.
So. Yes.
Correct. Perfect.
Okay. So this is our template for what we use for lab manuals. We start with the subject and the name of the experiment. And today I will be showcasing an acid-base titration experiment. Today I will be showcasing an acid-base titration experiment. We try to limit our
Es titulación. Título. Yes. Titulación. Algo así.
As Emina explained, we try to limit our labs in very short periods of time. And the experiment I will be showcasing will last for 8 minutes. In the gain section of our lab manual, we try to correlate to accredited high school curriculums. Then we go on with the theory section of our manual. The student can get background information beforehand of the experiment. Then we go on with the material section. the student can see all of the lab equipments and materials that they will be using in the lab. For the procedure section of our lab manual, the student will see the student can follow the steps and complete the lab. We try to simplify so the students can follow easily. For the calculations and tables section, we provide the student with empty graphs that they can fill. With the data that they collect throughout the experiment. We also have empty graphs that the student can fill with the data. So let's go on with the showcasing. I'm starting the experiment. And getting into full screen mode. For this experiment, we currently have 6 language options. And I will be doing it in Spanish. This is our lovely lab assistant, Amy. And she is now instructing me as to how to conduct the lab. We can pick up objects from the table with the left click of our mouse. Left, yes. And we can get into the theory section of our experiment. This is the same exact lab manual that we have looked before. And the student can follow each of the steps from the tablet. We can go back and click onto the experiment section, in which the student can reach to all of the tables and graphs. I am dropping the tablet with the right click of my mouse. And I'm placing the unknown solution to the analyzer. And the analyzer will tell me which solution it is. For this lab, we're using 0.1 molar hydrochloric acid. Indicate. Yeah, hydrochloric acid. Yeah, let's just say acid. Yeah, let's just say acid. Yeah, let's just say acid. And also we have the base.
Es ácido clorhídrico.
Can be tricky. So we're putting the base into the titration machine. And the student can see, if they pick up the object, where to place it with the blue label. The student can see as to where to place the object with the blue labeled image. And I'm now placing the indicator. The lab assistant, Amy, is now giving me information about the indicator. To start the experiment, I'm clicking on to the on button. And now the base is slowly dripping onto the acid. As we can see, the pH or the acidity of the solution is slowly decreasing. And after it passes a point, the indicator changed color. So the student can see that the solution we have is now more basic than it was. So as we're gathering data, it is being recorded on onto the table in the tablet. I can save my information by save my data option. And the data I saved will be under my data section in the main menu. I can also draw a graph with the data I've collected. And as we can see, the student can see a titration graph on the big table. The student can repeat the experiment by clicking onto the repeat the experiment button. And all of the materials are placed into their initial positions. So the student doesn't have to repeat everything again, and they can have a quick start. So thank you all for this showcase. This was the thank you. We can click onto the exit lab and we can look at the data that we have saved. It's under the My Data section in the main page. So this is all the data that I have collected from previous experiments. The student can print this out and include this to their lab report. Also, as you can see, we have various subjects of experiments in our system. Including experiments from junior labs, from the biology. So we cover a wide variety of subjects. So thank you so much, all of you, for listening to us. This was a great opportunity for us. Thank you.